So, in this class let us continue from the previous class, where we were trying to find out that whether the initial basic feasible solution whatever we have obtained by VAM or other methods, that is optimal or not. For calculating this optimality, in the last class we have told that I have to take the dual variables, means I can write down the transportation problem in the form of simplex model. Then I can use the dual variables u I and v j, and ultimately I will calculate u I plus v j minus c I j. So, let us discuss this thing using the flow chart. You start the problem, express the problem in tabular form. If it is a balanced problem, no, then transfer it in the balanced problem, adding dummy row or dummy columns and come to this place. This we will discuss if the problem is not balanced problem, how to convert it into balanced problem. Then if the problem is balanced, then is it a maximization problem? If it is yes, then convert it to a minimization problem by subtracting each element of the table from its highest element. If it is not, means if it is minimum, in that case find the initial solution using the northwest corner rule, VAM method, like that whatever method we have discussed earlier. That is, up to this we have done already. Once we have obtained the initial solution using the VAM method or etcetera like this, after that we have to check, that means after this basically this will come from here. I will come to from this place, I will come to this place, from here I will come to this place. So, here first I have to check whether is it degenerate problem or not. That is, if it is a degenerate problem, then remove degeneracy by assigning epsilon to the requisite number of cells. Again this we have to check how I can remove degeneracy. If it is no, then you have to calculate the cross coefficients. For the row you have to take this u I equals c I j minus v j, and for column you have to take v j equals c I j minus u I and assign an arbitrary index to the first row on the right margin. Then compute the approximate cost for each occupied cell by using the formula delta I j equals c I j minus u I plus b j. Or in other sense, at first we have to find out the values of u I and v j, and you can do it if I can choose arbitrarily one value, at least one value of u I or v j, then I can derive the other values. Once I have done this, c I j is known to me. So, I will calculate for each cell c I j minus u I plus v j value, which is delta I j. If delta I j greater than equals, the solution is optimal and we will stop over here. So, basically for optimality I have to check c I j minus u I plus v j is greater than equals 0 or not. So, please note this one. In the earlier also whatever we were telling, that I have to basically see this one, I have to calculate this u r plus b r minus c r s, and if this value is greater than equals 0, in that case solution is optimal. If all delta I j is not greater than equals 0, then select the cell with smallest opportunity cost. Draw a closed loop which begins and ends at that cell only. Please note this one. Select the set with smallest opportunity cost. Draw a closed loop which begins and ends at the cell selected. May pass over both occupied and unoccupied cells. Has the alternate signs in the root starting with plus sign in the chosen cell. Change the direction only at the occupied cell. Change the direction only at the occupied cell. So, please follow this step to draw the loop. That means, whenever your delta I j is less than 0, there it must form a loop. Please note this one. And how to draw the loop? that we are specifying by this step. Then a revised solution is obtained by considering the cells with negative mark and determine the list of the amount held. Then add this amount to the cells bearing plus sign and subtract the cell with the negative sign. That means, on this you find out what is the lowest cost, and that lowest cost will be added and subtracted depending on those on the cells of that particular loop. Then again you will check the is it degenerate or not. If it is not, we will repeat this particular process again. So, I hope it is clear that what we are going to do for this. So, now let us take one example, so that you can understand it in the much better way. So, I want to find out the optimum solution of this transportation problem. So, please note this one. I want to find out the optimum solution. So, at first what I have to do? I have to find out the initial basic feasible solution. So, at first I will find out initial basic feasible solution. Now, you know the method, so I will not describe the initial basic feasible solution. Directly I will write down. I am using here matrix minima method. So, we are using matrix minima method to obtain the initial basic feasible solution. Your initial basic feasible solution for this problem will be 1 2 1 4 3 3 2 1 4 2 5 and 9. These are the 1 0 2 0 3. I will not write later. This is D1, D2, D3 and D4. Here it is 30, 50, 20, 20, 40, 30 and 10. Your initial basic feasible solution will become this one. This is 20, this is 10, then 20, 20 and 10, and here it is 20. You can check here allocation is fine, 20 plus 10 30, here 20 plus 20 plus 10 50, here 20, column wise it is 20, 20 plus 20. So, 20 plus 10 30 and 10. So, allocation is fine. So, x 1 120, x 1 3 10, like this way you can write down. Now, number of cells m plus n minus 1, here it is how much? M plus n minus 1. So, 3 plus 4 minus 1, 3 plus 4 minus 1, this is equals 6. So, this is equals to 6 over here. So, this is 6 means how many allocations you have made? 1, 2, 3, 4, 5, 6. So, this is equals number of occupied cells. So, since it is number of occupied cells is equals to m plus n, so it is non-degenerate. So, now we will check, we will go for whether it is optimum or not. To find out the optimum or not, what I have to do? I have to calculate Cij equals Ui plus Bj for occupied cells only. Please note this one. I will check Cij equals Ui plus Bj for occupied cells. So, how I will calculate here? Here Cij equals Ui plus Bj. First occupied cell is this one, this is 1 comma 1. So, from here in terms of I is 1, j is 1, so that you will obtain U1 plus B1, this is equals to C11 and C11 value is 1, the cost is C11 is 1. The next one is this is the occupied cell and this is 1 3. So, you will write down U1 plus B3, U1 plus B3, the cost is equals to 1. Second one is this is 2 2. So, U2 plus V2 equals the cost is 3. Next is U2 plus V3, this is equals 2. U2 plus V3, this is equals 2. Then U2 plus V4, U2 plus V4, this is equals 1. And U3 plus V2, this is U3 plus V 2, next occupied cell, this is equals to 2. So, please note that I have to find out C I j equals U I plus V j for occupied cells, only for occupied cells, and C I j means the cost whatever I have written. So, I am getting these equations. From these equations, if you see, unless I am giving the value of one variable, then I cannot determine the value of other variables. This is, you can check it of your own. So, which variable I will make it 0? Out of this, I will choose the row which has the highest number of occupancy or allocation. I will choose the row which has highest number of allocation. Here if you see, row 2 has maximum of 3 allocation. Therefore, what I will choose? I will choose here U 2 equals 0. So, once I am choosing U 2 equals 0, then from this you can find out V 2, V 3 like this way, all others. So, once you are getting, so your values you will obtain U 2 equals 0, V 2 equals 3, V 3 equals 2, your V 4 will be equals to 1, V 4 will be equals to 1, U 1 will be equals to minus 1, V 1 equals 0 and U 3 equals minus 1. So, please note that by considering this C I j equals U I plus V j for occupied cells, I am forming the equations. I will choose one arbitrarily one variable as 0, otherwise I can't determine the values of other variables. What I am choosing? The row which has maximum number of allocations. Now, rewrite this table and from this one, rewrite this table by this way. You have 1, 2, 1, 4, 3, 3, 2 and 1, 4, 2, 5 and 9. Your allocations was on this 20, 10 here. Here it was 20, 20 and 10, and here it was 20. Now, you write down U I values on this side and V j values on this side. You already know from here what is U 1, U 2, U 3 and what is V 1, V 2, V 3 and V 4. So, those you write over here. So, that minus 1, U 1 was minus 1, U 2 is 0, U 3 was minus 1 and then V j is 0, 3, 2, 1. Now, compute delta I j equals C I j minus U I plus V j. Compute delta I j equals C I j minus U I plus V j. C I j is these cost coefficients, U I are these, V I j is this, and you compute this, you compute delta I j equals this for unoccupied cells. Please note this one. For unoccupied cells, compute delta I j this one. So, first unoccupied cell is this one. So, C I j minus U I plus V j. U I plus V j is 2, C I j is this 2. So, 2 minus 2, the value is 0. Similarly, for this 4 minus U I plus V j, which is 0. So, 4 minus 0, it will be 4. For this case, it will be 3 minus 0. So, it will be 3. These are occupied cells. For this case, 4 minus 1. So, 4 plus 1, 5. For this case, it will be 5 minus 1. So, it will be 4. And for this case, it is 9 minus U I plus V j, that is 1 minus 1, 0. So, it will remain 9. So, if you see here, all delta I j greater than equals 0 for all I comma j. Since all delta I j greater than equals 0, therefore, the initial solution whatever you have made here, that is optimum. So, your solution is x 11 equals 20, x 13 this is equals 10, x 22 equals 20, x 23 equals x 23 equals 20, x 24 equals 10 and x 32 equals 20. And minimum cost also you can calculate as usual, that is 20 into 1, 10 into 1, 20 into 3, like this way, sum of all the occupied cells, and minimum cost you will find as 180. So, this is a problem which explains that how to check the optimality. For optimality, basically you are calculating ui Cij equals ui plus Vj, where ui and Vj you are calculating for occupied cells, you are forming the equation, you are choosing one variable as 0, which you are choosing that variable corresponding to the row which has maximum number of occupied cells. Then you are getting the variables values ui and Vj, you are writing this ui and reformulating the table like this, you are writing ui and Vj. Then you are calculating delta ij equals Cij minus ui plus Vj, whose values are known, and for this problem you are finding all delta ij are greater than equals 0. Since all are greater than equals 0, therefore, your cost is minimum cost is 180. Now, let us take another problem which we will discuss this one. For this particular problem, this is given, your initial BFS will be, initial BFS is 274, 331, 547 and 1, 6 and 2. Here it is 5, 8, 7 and 14, 7, 9 and 18. Your initial basic feasible solution is this one. One will be in 8, then it is 7 and here it is 2, 2, 10. So, 5 will come here. So, 5, 8, 7, 14, 7, 9, 10 plus 8. So, you got this one. Now, from here directly you can calculate ui and Vj also from here. From this place by using u1 plus v1 equals 2, then u2 plus v3 I am just writing u1 plus v1 equals 2, u2 plus v3 this is equals 1. Next this one is u3 plus v2 equals u3 plus v2 equals 4. Next one is this cell, which is nothing but u4 plus v1, u4 plus v1 this is equals 1, then u4 plus v2 this is equals 6 and u4 plus v3 this is equals 2. Since row 4 has maximum number of occupied cells, therefore, you choose u4 equals 0 for this problem. So, once I am doing it, then you can find out the values of ui and Vj. Values of ui and Vj will be this thing, I am directly writing 1, minus 2 and 0, and for Vj it will be 1, 6 and 2. So, this corresponds to this corresponds to this. So, once I have calculated ui and Vj, then I can calculate delta ij equals Cij minus ui plus Vj using this formula. So, once I am doing it, now directly I am writing, since already you know how to calculate this one. here you will get 1, here it is minus 2, here it will be 3, then 6, it is 7. So, here you see for one case not all delta I j greater than equals 0, this one is less than 0, delta 2 2 which is less than 0. So, your solution is not optimal. So, once the solution is not optimal, you have to form a loop now. So, what you will do from this table, your negativity is coming on this point, your negativity is coming to this. So, therefore, I can start from here, I can go up here, from here because I have to travel whenever I am starting from this, I have to travel on occupied cells only. So, from here I can go up to this, then from here I can go up to this and then I can go up back to this, which will form a loop if I am writing like this way. So, now let me I have explained. So, let me just write down the occupancies. Here it is occupied, these are the occupied cells, your 7 is here and 2, here it is 2 and here it is 10. And you got minus 2 at this particular point, you got minus 2 over here. So, once I am obtaining this is your minus 2. So, as I mentioned earlier, from here, okay, let me write down the 0 values also. So, here it is minus 2. So, from here I am starting, I will visit this place, my arrow will be on the occupied cell only. Then from here I can go to a occupied cell only. So, my arrow will be on this. From here let me go to another occupied cell, arrow here, and from here directly I can go back to this one by doing this. So, like this way if you go, you form a loop. So, what you do? I have to make it minus 2 is there. So, I have to make it 0. Since I have to make this as 0, that means I have to add 2 over here. If I add 2, then only it will be 0. So, once I am making plus 2 here, so I have to readjust because always once I am making plus 2 here, so on this occupied cell I have to make 2 less allocation, that is I will make this one as 8 minus 2. Once I have made 2 less allocation, so here on this occupied cell I have to adjust it by allocating plus 2 here, and once I have allocated plus 2 here, so here again it will be 2 minus 2. So, your new allocations will be like this. So, what I have done on this, it was basically the value was minus 2. So, I am allocating on this. So, initially it was 5. Now, here I have given an allocation of 2 because plus 2 I have added on this cell. So, this is the added one. Here my allocation I have subtracted by 2. So, it has become 6. This allocation was unaltered, this allocation was unaltered, whereas now here I have added 2 on this. So, it will be 12, and once you are making 2 minus 2, that means now you are not allocating anything on this particular cell. So, since you are not allocating here, so obviously, once you have given an allocation to an unoccupied cell, out of this loop, out of this 4, one must be occupied 1. So, I am doing plus 2 allocation over here. Now, you may ask why plus 2 I have made? This is nothing but the minimum of the allocations whatever I have made on these occupied cells of the loop. So, minimum of this I am coming over here. So, this will be unoccupied cell, and once I am making it unoccupied, then again I have to, let me write down the values 274, then 331, 547, 162. So, once I am doing this, then following the same method, again you have to calculate the value of u I and V j, and then you have to calculate the value of delta I j, as we have shown in the earlier example. So, for this case, if you calculate, I am just writing the allocations 5, 8, 7, 14, here it is 7, 9 and 18. U I values are 1, -1, 0 and 0. Once you are doing this one, you should check whether these are coming correctly or not. You should verify these values, since I have not shown it, and here it will be 142. So, for the unoccupied cells, now again calculate delta I j equals, that is delta I j you calculate, and you know delta I j equals C I j minus u I plus V j. So, for the unoccupied cells, you calculate delta I j using this formula with the values of u I, V j and C I j. So, if you calculate, you will find that you are obtaining this. This will be 3, this value will be 4, this value will become 5 and this value which is 2. Now, if you see the value of delta I j is greater than 0. Therefore, greater than equals 0. Therefore, the allocation which we have made now, that allocation is optimum, and your optimal solution, then I can write down like this. Optimal solution is x 11 equals 5, then x 22 equals 2, x 23 this is equals 6, x 32 this is equals 7, x 41 equals 2 and x 43 this is equals 12. And the minimum cost, if you calculate, you will see minimum cost is becoming 76. So, I hope it is clear that whenever you do not have, you have the loop, that means whenever I am trying to check the solution, initial basic feasible solution is optimum or not. In that case, you are calculating first u I plus V j, u I and V j from the formula C I j equals u I and V j, and from there you are calculating delta I j. Delta I j equals C I j minus u I plus V j. If all delta I j greater than equals 0 for all I j, then the solution is optimal. If delta I j is not less than 0, you are forming a loop as I have shown in this example, and after forming the loop, you are adding the minimum weight over this negative value, and then accordingly you are readjusting, and then you are repeating the process what the way we have shown earlier. So, if the problem is non-degenerate, the way we have told, we can find out the optimal feasible solution of the transportation problem.